Hi guys, it's your guy Olumide, and today we are going to be solving another one of the most commonly asked tech interview question, the product array without current element. It is asked by top tech companies including Google, Amazon, Meta, Netflix, Spotify, Apple, Microsoft, and other top tech companies. The problem statement states that given an array of integers, return an array res so that res of I is equal to the product of all the elements of the input array except nums of I itself. And we are giving this example here, and what this problem statement actually does and what it wants us to do is that it wants us to return an array. You understand? So you return a new array res such that res of I mean the where I is any index in the array res. So res of I actually corresponds to the product of all the elements in the input array except I itself. For now, let's take I to be 0. I mean the very first index 0. So res of I now is gonna be 60, and that 60 means the product of all elements except this particular I. So res of 0, right, is just product of every other element in the array except nums of 0, except these two. And if we look into it now, 3 times 1 gives us 3, times 4 gives us 12, 12 times 5 gives us 60, and that's why we have 60 right here. So same thing applies to the rest of the elements. So rest of I, for I equals to 1 now, I mean the second index is just a product of every element except I itself, I mean except the value at I, which is 3. So we are gonna multiply 2 by 1. We are gonna skip 3 because it's just the product of every element except that 3. So 2 times 1 times 4 gives us 8, times 5 gives us 40, and that's how we go on and on in solving this problem. A straightforward solution to this problem is to find the product of every elements in the array nums, right? So finding the product of every element and then dividing this product by each of the numbers, each of the elements in the array, so as to obtain the product, so as to obtain the value for each of these elements. What I'm trying to say in essence is that first of all, we find the product, which is 2 by 2 times 3 times 1 times 4 times 5, and that gives us 120, right? So we are gonna divide 120 by 2 to obtain the value or the answer or solution for this particular index. Why? Because 120 is the product of every element in this particular array, but now the problem statement wants us to return the product of every element except the particular element itself. So every other element except the element. So if the product of every element could be 120, then 120 divided by 2 is gonna give us the product of every element from 3 to 5 except 2 itself. Why? Because we divide 120 by 2. And same thing applies to 3. Now we're gonna this total element, we're gonna divide it by 3 to obtain the product of every element except this element at this position, and we are just gonna continue like that. 120 divided by 2, 120 divided by 4, 120 divided by 5, and this is gonna give us the answer that we really want to get. So we're gonna be having the very correct array that we are asked, which contain the product of every element except the element at this particular index, and every product of every element except the element at this index, and every product except the element at this index, and so on, just like we have it here. This approach allows us to solve the problem in linear time and constant space. What I mean is that all we have to do is just iterate through the array once to find the product, right, and then iterate through the array the second time to keep dividing by their index, and then just in linear time, because we are doing we are iterating through the array twice, so that's linear time, right? Why? Because it's just 2n, where n denote the length of the array, so it still is linear, right? And also it takes linear space and constant space in the sense that we don't really need to create any other data, any other data structure to store the data. So don't forget, fine, we might be returning an array, a new array, but we are not going to be including this among the space calculation. I mean it does not include the space complexity, right? This particular res that you are seeing here, because it is the output output array, so we are not going to be adding it to the space whenever we are calculating space. Don't worry, more on time and space complexity in our subsequent videos. So but right, but a follow-up question, fine, this is a very good approach because it takes linear time and it takes constant space. But a follow-up question by interviewer is that what if we can't use division in solving this problem? What if division is not permitted to solve this problem? How do we go about it? Well, an important observation is that the output for any given index I mean the output results for any given index I can be calculated by multiplying two things. So we can determine the output by multiplying for any index in the results, I mean in the output results, by multiplying two things. First is the product of all numbers to the left of the index, and second is the product of all numbers to the right of the index. This is what I'm trying to say now. So to solve this solve for this particular index 0, right? Okay, to get the output for this particular index, that's okay, to get 60, we can achieve it by multiplying everything to the left of 0, which is nothing actually, right? Because this is the first index, so nothing is to the left of this. So let's just say that it is 1. You understand? So that is every product to the right of to the left of this index 0 is 1, and every product to the right of this index index 0 is 60, right? Because this is 3 times 1 gives us 3 times 4 gives us 12 times 5 gives us 60. So that means that we can observe that for any particular index I, the answer, to determine the answer that will be in the corresponding output is just calculated and determined by multiplying the product to the left and the product to the right. So let's consider another example now for this particular one, for this particular index 1. So to calculate and to determine the product of all elements of this particular index except this index itself, what we just need is a product of every element to its left, which is 2, a product of every element to its right, which is 20. 1 times 4 times 5 gives us 20, right? And 2 times 20 will give us the 40 that we are expecting. So that way we can be able to efficiently remove the index itself, or the value of that index, from the equation by multiplying everything to its left and everything to its right. So, and that's why I come across this observation that the product of all number to the left of the index and the product of all number to the right of the index are the two major things we need in finding and in determining the product of every element in the array except the index itself. So this is what I'm trying to talk about here, right? So to determine the sum, the product of every element except this index, except this value at this index, all we just need is product over here and the product over here in this shaded region. And we can see that the product here is 6, the product here is 20, and then 6 times 20 will give us the result, which is actually 120. And if you go and look at the answer right here, you see that we have a 120 in the place of 1. So that's simply what we want, and that's simply how to solve this problem. And what is this trying to tell us? What this is trying to tell us is that if we can pre-computed, or if we have pre-computed all products to the left and to the right of each input of each index, then we can easily get and determine the product of the products and the output for each index. I mean in the rest output, if there's a way whereby we have pre-computed the product to the left, or let me say the product of all elements to the left and the product of all elements to the right of each index, then you can easily get the output array, which is the result array for each index. To understand this better and to explain more further, we will need two arrays. The first one will contain the left product, an array where left product of I will represent the product of all values to the left of I, and we will need an array right product whereby so is an array where right product of I is the product of all values to the right of I, right? So this means that we'll be needing two arrays. One is gonna contain the product of all value to the left of I. The other is gonna contain the product of all value to the right of I. Now to obtain the left product, I mean the left product array, we need to keep track of the cumulative products of all value that we encounter as we move from left to right. And then what I'm trying to say in essence is that right from here, as we move from, we are going to be iterating from left to right in this pattern, from left toward the right. After doing that, we will now be keeping track of all value that we encounter to the left as we move from left to right. So when we are currently at the very first index, which is index 0, we see that the value we encounter to the left, we don't really encounter any value because this is the very first value, so there's no value to the left of this particular index 2. So we're just going to set 1 there. Why? Because there is no, we need the product of all elements we encounter to the left, right? So but currently at this particular point, this first index, it has no value to its left, so the product is just going to be 1. So but as we move on to 3 now, which is the second index, we know that the product we have encountered is actually 2 times 1, so, or simply 2, right? So we're gonna put that 2 right here. So then we move on again to this point, and now we know that to keep track of the running sum, the value we have encountered will be 3 times 2, which is 3 times 2 right here. Or you can say that 3 times this last value here, which is 2, right, which give us 6. That is this means that every value to the product of all elements to the left of this index, which have element 1, is 6, which is 3 times 2. So as we progress again to this next index, so as we progress now, we need this left product. We keep track of the elements of the product of the element to the left of this index 4, which means 1 times 3 times 2, fine, so which is 6. So but instead of having to iterate through every damn time, iterating through 1 times 3 times 2, we can just take the last value here and multiply it with the last value here, which means 6. So as we progress also to 5 now, we can just take the last value here, which means 6, and multiply it with the last value to this place as well. So it's just simply the same thing as saying that 4 times 3 times 2 times 1. Why? Because this 6 that you are seeing here actually corresponds to the product from 3 times 2 times 1. And then to find all the product of all elements to the left of 5, we just have to multiply that 3 times 2 times 1 by 4, so that we can keep up the running sum. Similarly, the same thing would apply to the right product, and all we have to do is just is to start from the right to the left. So when we are keeping track of the right product array, we just start from the right and we narrow down to the left. And what we do is that, fine, starting from the right, this is the rightmost index, which is the last element in the input array nums, right? And what we want to do is that we want to check that to the right of this particular number 5, to the right of it, what are the running products? What are the products? There's no product actually, because this is the very first element to the right, fine. And because of that, we're gonna put 1 here, because this is the very first element, and the product of all elements to its right is just 1, because really there's no product to its right, it is the rightmost element. So moving on to the next rightmost element, which is 4 in this case, all we want to do is just to multiply 1 by 4 and 1 by 5, so as to keep the running track. Why? Because the product of all elements to the right of 4 is just 5, so we can multiply 5 by 1, which that way, fine. Moving on again to this 1 again, which is to the right, all we just need to multiply, all we need to find is the right product of all rightmost elements to 1, which is just 4 times 5. But like I explained the other time, instead of having to do 4 times 5, imagine if it's so long, we just keep multiplying, which will take a linear time, on time, right? So instead of doing that, we just want to multiply 5 times 4, because what this particular very last element here, or let me say latest element here, actually contain the running product already, so we don't need to be iterating through all and all and all. So, and because of that, 5 times 4 will give us 20. So the value here will be, that is, this 20 represents the product of all value to the right of 1. Fine. Okay, now what we're gonna do again is that we now move on to 3. And now for 3 also, we just want to find the product of all element to the right of 3, which is 1 times 20, and that's why you see that there's another 20 right here. Fine. Okay, and then we move lastly to this 2, and moving to 2 now, we just have to multiply 20 by 3, which means that the product of all elements to the right of 2. So simply that's it. And now after we have this left and the right products, we can simply get our result product for each index simply by multiplying left of I by right of I. Why? Because left of I represents all elements in the product of all elements to the left of I, and right of I represents the product of all elements to the right of I. So to get the answer that we are looking for is just by multiplying that left of I and right of I together. So which we see this is 60, this is 40, this is 120, 30 and 24. So the difference between preface sum and preface product is that instead of cumulative addition, as we have been doing in our subsequent videos, when we treat the sum range, when we treat the case sum, array and some other problems, we have been using cumulative addition. And what that means is that we have been adding on, you know, to find the running sum. But rather now we are going to be using cumulative multiplication, just like I explained above here. So you see that we are using cumulative multiplication by multiplying the running sum by, you know, multiplying 5 by 5 by, you know, just like I explained the logic right now. So that's how we'll be doing it. So another difference is that we initialize the preface product array with 1 instead of 0 to avoid multiplying the cumulative product by 0. So if you see here, you might be wondering that why don't we just initialize with 0? No, we don't want to keep having a 0, because anything multiplied by 0 is gonna give us 0. So we have to keep it as 1, right? So we are initializing as 1. But if we are finding, if it's preface sum now, probably we're just summing up, we can initialize to 0. So and this is just the visuals of how we do it, just like I explained the other time. So this is just the visual. Look now, we place for the left array, the leftmost is gonna be 1 by default. Why? Because there's nothing actually to the left of 2. So if we want to find the product of every element to the left of 2, we're just gonna put in 1. We're just gonna put in 1, right? And then we're gonna move on to the next element now. So and this next element will just be 2 times 1. Why? Because this one also will be the value for the value for this particular index, I mean for 3, will just be the product of all elements to the left of 3, which is just 2 times 1, which gives us 2. And similarly, as we progress to the next index, which is 1 now, it will just be 3 times this 2. It will be 3 times 2 right here. And as we progress again to 4, it will be 1 times 6. And why we are doing this is because each time we find the left product of a particular index, that index becomes the running sum. Why? Because okay, look at so far from this point now, from this point 1 times 3 times 2, you know, that's what make up 6, right? So right, that's what make up this 6 here. So instead of having to do the same, you know that for 4 now, if we want to calculate for 4, we still want to find the product of every element to the left of 4. So instead of doing it and, you know, multiplying all through in linear time, we can just get the very last element in the left product and multiply it by very last elements in the norms as well. So that will give us 6 times 1. That will give us 6. Why? Because this last product this last element in the left product array is just is actually the running sum of this. You can see it here, is the running sum of this. So now to get the value for this number 4, I mean the left product corresponding value for 4, we just have to multiply that running sum by 1, and to get for 5, we just have to multiply the running sum that we obtain, the latest running sum, which is 6, which is this 6 here. So which we obtain for this value 4, we just have to multiply it again by we have to multiply by 4, and that's why you will see it as 24 right here, right? So it's just what I explained the other time. So to find the right product array, right, we do the same, but we do it starting from the right. So the product of elements to the right of 5 is just 1, right? And because of that, we place 1 there. We initialize it by 1. Why we initialize it by 1 is because we really 5 does not have anything to its right, and we cannot place 0 there because it's just gonna keep giving us 0 for the rest of the running sum. So we have to put it as 1. So when we approach 4 by moving from the right to the left, we are gonna multiply that 1 by 5 to give us 5. So when we move to 1 again, when we move to this one again right here, we're gonna multiply 5 that by 4. That's how we keep doing it. So it's gonna give us 20, which is here, this one 20 here. So again, when we approach 3, it's gonna be 20 times 1, and when we approach 2, it's gonna be 20 times 3, right? So, and that's how we solve this problem. Alright, we'll be going into the code implementation now to explain and to work it out. So don't forget, all we just need to do is that we're gonna be given the norms array, and we want to find and want to return an array whereby rest of I is equal to the product of all elements to the left and to the right. So we just need to create the left product, which is the cumulative product from the left to the right, while the right product, which is the right product, which is the cumulative product from the right to the left. And then from there we can easily get our result output or result array by multiplying left of I and right of I. So we are gonna be going to the code implementation now. Alright, let's go into the code implementation for this particular problem. It is the product array without current elements. So, and we are gonna be passing in the norms array, which is our list of integer, right? And then what we want to return is actually the products, which is also a list of integers. So products for each of the indices. So I mean the products of the elements except the particular index. So just like we explained in the logic. Fine, let's define the parameters like I used to, and then I really want to call my print. Let's call the function product array without current elements, so we know what we are working with and what we are working on and where we are going. Okay, now if you recall, I talked about defining two things: the left product array, which is actually an array, and the right product array, which is also an array. Fine. And also the rest array, which is gonna contain the new array which contain the product without the element. So one thing we wanna do is that to solve this problem, we're gonna initialize it with a 1. So don't forget why I said that 1. I said 1 because we don't, we're gonna be we don't want to be multiplying. We are finding the cumulative product and we don't want to be multiplying by 0, so we have to initialize it with 1. So same thing we apply here, initialize with 1. So same thing could apply here to initialize with 1. Fine. Do we even need to initialize rest? Well, we can decide to, we can decide not to. So but it's quite important we initialize left product and right product, because take for instance when we are trying to okay, you will see in the code implementation as we move on. So now let's find the left product. Don't forget, left product is gonna start from the left to the right and it's gonna be doing the cumulative products for at each of the index. So let's do that now. For I in range of 1 comma len of norms. So you might be like, why do I start from 1? We have to start from 1 because for the left product now, don't forget that for the very first element in our norms, the running sum is 1. Why? Because the product of all elements to the left of this first element is actually 1, because there's really no element to the left of this one. So we just have to initialize it by 1, and when we want to start our iteration, we can continue from the next element here. So we already have the value for this as 1 by default, so that's why I'm starting from 1. So iterating through index 1 onward, what we now do is that we want to see our left product of I is equals to left product of I minus 1, so times norms of I. So right, we're going to take the running sum, the previous running sum, and multiply it by this current element. So in this case now the previous running sum is 1, we just have to multiply it by it's even norms of I minus 1 if we follow on with the logic, so we keep on multiplying by the previous one as well. So that's what will give us the value for this particular 3 without, I mean the left product without this 3. So had it been, we say that nums of I now is going to be including 3, so and we don't want that, so it has to be nums of I minus 1, so that it will be the product up to the very left, strictly to the left of the index that we're working with. So fine. And then we can just say we can do the same for our rights now, our right product. But in doing the same for our right product, don't forget we have to start from the right and not the left. So we can just say for I, let's use the same I for I in range of. So now we want to do len of nums minus, it's supposed to be -1, but we're gonna be using -2. Why? Because we already len of nums minus 1 is gonna target the very last index, I mean the very last element in the array nums, right? But we just wanna target right from this. Why? Because we already know we want to target from len of nums minus 1, that is one more to the left, because we already know that the product to the right of this last element is 1. So and we already initialize all our right product as 1, so we don't need to consider this very last one again. We can just start from the second to the last, and that's why I'm having -2. So we'll be doing -1. Why I'm doing putting -1 here is because we are going to be moving right from this element here up to the end, 0, up to 0, you understand? So I want to cover the whole element toward the left, and when I'm putting the last -1, I mean this particular -1 here, is because I want to be taking the step one time to the left, so that I can reach each and every one of the elements, right? Okay. Please do well to like, to comment, and to share, please, and subscribe to my YouTube channel, please, I beg of you. Thank you. Okay, let's move on now. We are very sure now that we are starting from this point and we are moving to the left. I mean we are starting from the right toward the left, moving to the left. And what we want to do is that we just want to populate our right products. I mean is actually populated. No, it's P, it's supposed to be P here. So right, so it's actually populated, but I want to modify it so that right product of I will become equals to right product of I. If you are following through, you will see that it's gonna be I plus 1 now. So it's gonna be right product of I plus 1 because don't forget that starting from this right and moving toward the left, the running sum is gonna be at, you know, I plus 1. It's gonna be in the front, not like in the left product that is actually at the back. So right, it's just logic. So and after doing this, we're gonna be multiplying it by the nums of I plus 1. Similarly, why? Because nums of I plus 1, let's say that our I is at this particular index, which is the second to the last index, so nums of I plus 1 will be here, right? So you see why everything is to the front, because we are starting it from the back, so we have to be comparing with the front there. So now after doing this, we will have our left product and our right product. So what we just want to do is to iterate through let me see this I range of len of nums. So and what we want to do is to populate our rest array. Not really populate, it's already populated with once, but now to put in the right value there. So and now we just have to do what we just have to do is rest of I is equals to right product of I times multiplied by the left product of I, right? And why we have to do this is because right product of I corresponds to the product of all elements to the left of I and to the right of I. Left product of I also corresponds to the product of all elements to the right of I. So let me just, so as to make it less complex, let me do it this way, times. I should put the times here. So and then we can just simply return res. You might be wondering why I do space my code. Well, one major reason why I space it is because while I was learning how to code it's it was not how to code and how to solve DSA problem. It's not very easy. It takes time, and really for every line I have to really break it down. I have to really space it very well, because it can be very complicating and intimidating. So, and that's why it's now part of me to always space my work. So I believe you too can understand it now. All right, let's run this code and see how it goes. It's normal to encounter bugs when solving problems. So once we encounter it, we're gonna solve it as well. Oh, I guess you would have already been telling me, yelling at me that, oh, why would you have to multiply it by 1? Really, we are gonna be multiplying by len of norms, right? So we are populating it with the same number of elements that is in norms, not 1. So right now it's getting me a list out of list as assignment index out of range. So it's supposed to be len of norms, so not 1. Let's run it and see what happened now. Oh, I think we are giving the right answer: 60, 40, 120, 30, 24. So this is the right answer now. And well, there is more optimization to this problem that you can see here. Lots more optimization, but to make this video short, I really just want you to understand the logic behind it. So there are still you can still devise a way to further optimize it. So thank you for listening, and stay blessed.